Petroleum geology technology. Thinking about new ways to do catalytic refining of petroleum products, as well as a different thing, alkylation, which is where ene alkanes combine to become lengthier alkanes, sort of like going from methane or ethane to create octane. I think that there are technologies, which may already exist online, that I'll describe. I think it's possible to combine solar warmth with catalytic refining to produce petroleum products at higher efficiency. I read at a tome of knowledge that I think may have been published near the 1970s AD at the United States, that about 3/10 of the energy used to do catalytic refining of higher mass alkanes to things the size of octanes, that was about the efficiency. 3/10 of it went to the chemical process, 7/10 of the material became the product. So because a person could use solar thermal to actually warm the catalytic refining chemical reactor, perhaps you could get 9/10 or even 10/10 of the actual hydrocarbons to reach the catalytic refining temperature with the solar warmth from something like a large array of reflective mirrors. So that's the kind of thing where if you think about the oil of Canada, where it's quite sunny during the summer, or the oil of the Middle East, where it's also, they have lots of solar availability, that would cause the actual proven availability of the amount of petrochemicals from those places to go from 7/10 to 10/10. So if there's an area that might have 100 or 700 years of actual petroleum availability, suddenly that would be the equivalent of having 130 or 1,000 years of petroleum availability just from using the solar thermal to do the catalytic change of size of the alkanes. So I'm thinking, if I look this up online, would I find that many petroleum geologists had created publications about doing a combined solar petroleum catalytic process? I don't know. So a completely different thing than making lengthier alkanes to become octane is actually causing littler molecules to do something they call alkylation, which is to become lengthier alkanes, so turning methane or ethane to something like octane, a liquid fuel. So at chemistry, I learned about how you can use halogens with ultraviolet light to turn methane to a methane ion. Then methane ions are able to combine with other methane ions to create ethane. And it's possible that ethane could create something which is perhaps called an ethane ion with other ethane ions to create longer alkanes. So how is it possible to improve that process? Well, if there's already a engineering physical improvement to using solar warmth to convert part of a hydrocarbon resource from gooier liquids to octane, it's possible to co-locate an alkylation plant near that to convert things like methane or ethane to octane at an area very near the area where there's already a solar thermal reflective array. So this suggests that the solar thermal reflective array actually divide the light to UV as well as thermal. So there's a variety of approaches to that. There's optics, of course. You can just have the concentrated light travel through something optical so that it divides the different frequencies to go on different pathways. And the UV light goes to the alkylation reactor, which is completely different than the warmth effect traveling to the catalytic refining reactor. So it's possible that the co-location of those solar effects to improve petroleum geology efficiency is a benefit at a variety of areas of the Earth. And the thing that I noticed about this is, again, if it was 7/10 of product from process, because some of the product went to produce product energy, there's a much larger amount of actual product producible. It's like creating something similar to 3/10 more petroleum reserves just from doing a combined solar with catalytic process.